So let's get into it. We need to classify matter into the three types of substances. We've already learned about two of them. Elements are a type of substance that is made of all of the same atom, and compounds are substances that are made of all of the same molecule. These two things together, because they're made each one of all of the same particle, are considered pure substances. And we call them pure because there's only one thing inside of them. In the same way that people talk about like a purebred dog, then its parents were like Labradors and their parents were Labradors and so on and so on. So it has one kind of dog inside of it. Pure substances only have one type of particle. But because there are only 90 elements that exist on Earth, and then only so many combinations that they can be put together, truthfully, most of the things that you and I know and love are actually a third kind of matter called a mixture. And mixtures are made of two or more particles. So compounds are not mixtures because they're stuck together, different atoms that are stuck together in fixed ratios. And elements are not that either because it's only one type of particle. Mixtures are made of two or more types of particles. So how do we make a mixture? Well, I mean, if you think about it, we make mixtures all the time. Like particularly if you ever spend any time in a kitchen, you're probably doing a lot of mixing. So, water is H2O and sugar, C6H12O6, are both what? That's right, they're both compounds because they have a chemical formula. So we know exactly what they are, we know exactly what's inside of them. Now if I take water and I add it to sugar, the atoms don't like rearrange and form new things. We're going to get to that in a little bit. What we get is a mixture of sugar water, where we have H2O molecules and C6H12O6 molecules, and they all float around and mix together so that they're all spread apart from each other, and we get sugar water, which is a mixture. So, even among mixtures, though, we have to have more categories because scientists love a category. So, two kinds of mixture. We have two prefixes we need to know. The first one, homo. Homo means same. And the second one is hetero. Hetero means different. Often these are used in terms of people's sexuality. Homosexual people are attracted to people of the same sex. Boys to boys, girls to girls. Heterosexual people are attracted to the different sex. Has nothing to do with what we're doing right now, but it helps you to remember. Homogeneous mixtures look all the same. You can't see the different parts. Heterogeneous mixtures, on the other hand, you can see the different parts. So the key here is what the words actually mean. Same and different. For example, a sugar cookie. You mix a bunch of things together, flour, sugar, butter, blah, 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 get a sugar cookie, but you can't see the different parts because it's mixed really evenly. Chocolate chip cookies, on the other hand, not the case. You can see the chocolate chips separately from the rest of the cookie. So because you can see that one part, it's considered a heterogeneous mixture. So let us look at some different objects. For example, here we have some Kool-Aid mixed into water. And as you can see, the Kool-Aid is mixed completely in. You can't tell anything different from the Kool-Aid in the water, so it's homogeneous. Here, we can see pepper flakes in a mixture of pepper and water. So because we can see the pepper flakes, this mixture is a heterogeneous mixture. We can see the pepper separately from everything else. Now, here we have some beads and water, and indeed we can see the beads separately from the water, so beads and water is heterogeneous mixture. Then we have rice. We mix rice into water, but it didn't completely mix in, so because we can see the rice separately, the rice in water is also a heterogeneous mixture. We have some blue food coloring, and you can see here that it is mixed completely evenly. You can't see the food coloring separately from the water, so it is a homogeneous mixture. And lastly, we have some flour that we put in water, and you can see the flour didn't mix in completely, it's just kind of clumpy on the bottom. So it's a heterogeneous mixture because we can see the flour separately from the water. Now, all of the things on the right over here are heterogeneous because we can see at least one part of that mixture. If you make chili, if you make a salad, you can see the lettuce, you can see the beans, so you can see the different parts. Whereas a homogeneous mixture, it all is mixed in really well, like chocolate milk. You got chocolate, you got milk. You can't see either of the different parts separately. Looks like one thing, so it's homogeneous. So the last thing I need to share with you is a little chart, a flow chart, a diagram, if you will. Because scientists, we love us a categorization chart. So when we're looking at matter, if you have a substance sitting in front of you, the first question you want to ask yourself is it made of one particle or is it made of many particles? If it is made of only one particle, then we know it's a pure substance. And if it's made of many particles, it is a mixture or mixed matter. So with pure matter, we have mixed matter. Further, we can separate with that pure matter if it's made of one kind of atom or one kind of molecule. You should know this. If it's made of one kind of atom, it is, that's right, an element. And if it's made of one kind of molecule, then it's a compound. They're both pure matter because they're made of only one thing. Now, on the other side of the spectrum over here, our mixed matter, we have to look at our mixed matter and say, okay, does it look all the same throughout, or can I see the different parts? If it looks all the same, then it's going to be called a homogeneous mixture. And if we can see one or all of the parts separately, we're going to call it heterogeneous. So if you take ice cream and chocolate and milk and you mix them up and you make a milkshake, it's homogeneous. You can't see the different parts. But if you have ice cream with the chocolate on the top, it's a heterogeneous mixture. Elements typically are shown with just like a bunch of circles. This is a bunch of atoms. Compounds are usually shown with a diagram that shows us a bunch of the same molecule. Notice that they're all the same molecule, an open circle and a shaded circle. Even though they're two different things, they're stuck together, it's the same particle. Homogeneous mixtures, because they're mixed so evenly and they look all the same, typically look like a pattern. If you were to look at it under a microscope, this is what it would look like. It would be an evenly mixed pattern so that when you zoom out of it, it looks all mixed through perfectly the same. And lastly, heterogeneous mixtures, they're just going to be all over the board because it's a bunch of different stuff that's all kind of split apart and all clumped together. So the last few little tidbits for you, a little clues to help you know what's what. If it's on the periodic table, it's an element. If it has a single atomic symbol that is one or two letters, one capital and a lowercase, it is also an element, okay? We know something is a compound if, first of all, a diagram shows a bunch of the same molecule, but secondly, if it has a chemical formula like H2O or CO2 or something like that, we know that it is a compound. Homogeneous mixtures look like one thing. So if you know that there's a bunch of stuff mixed together, but then at the end it all looks like the same substance, it's definitely a homogeneous mixture. Also, if you know there's a bunch of things that are mixed into it, but it all looks like one substance, like sugar water, then it's definitely going to be homogeneous. Heterogeneous mixtures, if you can see one part that looks separate from the rest of the substance, then it's definitely a heterogeneous mixture. One of the most frustrating things to students is not being sure how to tell compounds from homogeneous mixtures. Because if something is an element, usually it has a singular element name. Hey, this is magnesium. Hey, this is chromium or whatever. But when you're looking at, and when something is heterogeneous, like a chocolate chip cookie, you can very obviously see one part. So telling if something is an element or a heterogeneous mixture typically isn't problematic. But telling if something is a compound or a homogeneous mixture can sometimes be a little bit challenging. So let's take a look at a few kind of common substances. Here I have what is first aid antiseptic. It says povidone iodine topical solution, 10%, okay? So iodine, we know, is on the periodic table of elements. So at first you might be like, oh, maybe it's an element. But if we turn it around and we look here, it says up here at the top, let me get it focused for you. Active ingredient is povidone iodine, 10% of available iodine. So there's definitely iodine in here, which is an element. But if I cruise down here, it says other inactive ingredients are citric acid, disodium phosphate, glycerin, nanoxyl 9, purified water, and sodium hydroxide. So in that case, we can see that there's a lot of different stuff in here. So this thing, even though it looks like it's one substance, is definitely a homogeneous mixture. Okay? Another way to know if something's a homogeneous mixture is if it says solution, that means things are dissolved inside of it. So solutions are always homogeneous mixtures as well. Let's take a look at another substance. So here is baking soda. It's used pretty often, you know, if you cook in your house, and it's just like a white powdery substance when it comes out of here. So if we look here on the side, it says that the ingredient is sodium bicarbonate. There's no commas in between. Sodium bicarbonate is actually NaHCO3, I believe. So it is a compound because it has that name. We're not going to get into naming. That's a high school chemistry thing. But as far as, you know, our 8th grade science learning goes, sodium bicarbonate is definitely a compound because there aren't multiple things listed on the ingredients. Whoop, come back here, little friend. Focus. Focus. Okay, there we go. So how about we take a look at Kool-Aid? When it comes out, it's kind of a reddish powdery substance. And if we look, where's our ingredients? There's our ingredients. Boop. Hey there. Sugar, comma, fructose, comma, citric acid, less than 2%, ascorbic acid, artificial flavor, calcium phosphate, artificial color, red 40, BHT preserves freshness. So this is definitely going to be a mixture. When we mix it in with water, it's homogeneous, as we saw earlier. You can kind of see the sugar in it here, so we could also say it's heterogeneous. But we know it's a mixture for sure from that. Now here's another one. We have magnesium citrate, and that is a chemistry word, so it could be it could be a singular thing. But if we look here, there's a key. It says solution. And as I just showed you, solutions typically mean that things are dissolved in water. So if we look a little bit more carefully at our ingredients, we can see it says citric acid, flavors, purified water, saccharin, sodium bicarbonate, along with the magnesium citrate that's listed in the active ingredients. So this is definitely not a singular thing. This is a homogeneous mixture. Okay? How about this guy? Here we have a bag of sugar. And if we look here on the side, the ingredient is granulated sugar. Again, this is kind of a science thing. I know that sugar is C12H22O11, so I know that inside of here is a compound. And a lot of that just comes from further knowledge. The things that you're going to be asked to know more often than not are going to be looking at the differences here between diagrams and noticing that these things are molecules that are stuck together and these things are two completely separate particles. Also, if it has a formula or if it does not have a formula. So don't get yourself too upset in that. If you choose to continue with your scientific learning because there is just an abundance of it in the world, then eventually that will become much more clear to you as you move on. But it has to do a lot of times with just asking questions, you know, what's inside of things, does it have a chemical formula, that kind of stuff. So, two types of matter, pure and mixed. Within each of those, we also have two separations as well. So this is a good thing to probably write down in your notes somewhere if you need it, if you're studying. And make sure that you know the separation of the different types of matter.